So today you guys will be able to write the names of ionic compounds. So you guys will use the formula to write the name. You guys will use the name to write the formula. And that includes that polyatomic ion sheet that you guys have there. Okay? So you guys should all have this flowchart out. No, not that. Where is this one? Why wouldn't it be? It's good. Ship shape. Yep, you guys are doing writing formulas first. So find the one that says writing ionic formulas.
No! Get that thingy and set it on the markers.
I can't because it's my speaker.
Alright, that works. That really actually works.
It's my pit now. Alright guys, you guys above this can write if given the name. You guys are writing the formula. If I give you guys the name, you'll write the formula. Maybe I'll come over here. Is that too far, Grace? You probably can't see the board. Maybe if I pull it closer towards me. Like, put it more in front of you guys. Exactly. You can watch the video online. Is that too close? Are you ready for, can you see the board? Okay, crank the tripod. No, just turn the tripod base. And no! The base! Tripod base. Keep going. So it's like both the, there you go. There. How's that? She'll buff. Alright. So you guys, again, if given the name, you guys are writing the formula. Again, this is ionic. What's the first question you guys always ask? Yeah, is it a metal? Does it have a metal in the very first? Okay. So is this compound a metal and a nonmetal or two nonmetals? I feel like this thing just gave me elevator eyes. It's just like, yeah. See, it's doing it again. It's checking me out.
Yeah.
It's checking me out. It's giving me elevator eyes. I don't know. It's creeping me out, though. Some perv on NSA. All right. You know what it is, right? It's good. Can you see the board? I mean, that's...
No, like the top half of it cut off. Like after that third arrow, she's gone.
There you go.
Yeah. Oh, my land.
So just keep going down with it. Maybe you missed it.
What's the pumpkin? Can we just hold the camera? Wouldn't that be easier to hold it?
You would think.
Oh, I guess I can grab my notes and hold it.
Seriously, just turn the auto rotate off. Yeah.
How do you do that?
There's probably a switch on the back.
Yeah.
Wait, there's this button. Here. No, it's this button.
That's weird.
Nice close-up, Miss Crawford.
Okay, you adjust it from your side. Oh, yeah.
Is it not going to move now?
No, it shouldn't move now.
Well, it's still going down.
Is there some way to just just unplug it and then have the iPad just be sitting
I
there?
don't know what I'm hitting.
Yeah, you can just have it on the tripod.
Yeah, can I unplug it?
No.
Because it won't.
That's
No,
the
that's
sound.
the
That's the
sound
sound.
thing.
Well-
There, it's good now.
Go to the microphone.
Go sit down.
All right, don't move.
Don't breathe or anything into my steak.
Metal and non-metal.
Don't be awkward.
Oh, what's going on?
Catch up.
You know what it is.
I'm gonna trip on this stupid pumpkin.
That would be kind of comical.
Make sure you take their pumpkin.
That is
Have a
rude.
polyatomic.
I paid $49.
I want to play soccer with the pumpkin.
Oh my God.
Have we brought in the pumpkin yet? No. Okay.
Okay, guys. Hey guys, let's focus now. We need to get through a lot today, so. All right. Next question you guys are gonna ask yourself once you figure out it's ionic, it's a metal and a nonmetal. You guys are gonna ask yourself is, does it have a polyatomic ion in it? So you guys will be able to recognize this because A, you've memorized these, right? Your quiz on this is next Wednesday. you will have memorized them. So you guys will see it in the name and you say, hey, I recognize that. That is a polyatomic ion. Its formula is this. Okay? You guys will also be able to look at the suffix on the end. If it has ATE or ITE, it is a polyatomic ion. Okay? Or if it has hydroxide, ammonium, and cyanide. Okay? So all of your polyatomic ions end in ATE or ITE except for hydroxide, ammonium, and cyanide. So those are your three exceptions. So you'll look at the name. Does it either end in ATE, ITE, or does it have hydroxide, ammonium, or cyanide in it?
I think
It's a wee little box.
Are we supposed to write it in a box? Or write it on like...
So it's not tomorrow, it's next Wednesday, correct?
I think so, Marine.
You never really miss much.
Why is it?
It has got a mind of its own.
Why does it feel the need to shift around when you're just standing still? It can't even perform the function for which it was built.
I don't know. All right, we're good.
It's like in
All right, the yes, we're going to go the no route first. What? We're in the struggle bus with this thing. All right, the no route. Okay, so it does not end in ATE, ITE, nor does it have hydroxide, cyanide, or ammonium in it. Okay, so we're going to go with the no route. You guys are going to write the symbol and the charge for the metal. Then you guys are going to write the symbol and the charge for the non-metal. Remember that time I told you guys at the beginning of the year that everything we do in chemistry builds on it? So if you guys don't get one thing, it's coming back to haunt you on another thing. Okay, so with this case, ions, they haven't gone anywhere. They're here to stay. Okay, how do we figure out the symbols, the charges of an ion? No? What's the easiest? We wrote it on our periodic table is the easiest way. Yeah, we can calculate it from our number of valence electrons, but the easiest way to look at it is, hey, we wrote it on our periodic tables. Okay?
The quiz for this is tomorrow.
No, the quiz for that is next Tuesday. I moved it back. There is a quiz tomorrow, however, on Lewis.structures. Yeah. You guys may use your notes on those. However, if you guys were gone that day and you just took a picture of notes, make sure you get those written in your notebook because I won't let anybody use their phone. Maybe do that before tomorrow because it might help you. Maybe there's an example that I gave you guys that's on the quiz. That would be beneficial. I can't say that there is. I'm just saying. Okay. What you guys are going to write before this, like next to this next little box, you guys might want to write a star if the charges do not cancel. Okay, do a little star before the next box if the charges do not cancel. Then you crisscross the charges to make a neutral atom. Or a neutral molecule, excuse me. If the charges do not cancel, crisscross them to make a neutral atom. Again, we'll talk about more what this means when we do some examples. But what you guys do need to know is crisscrossing is just a math trick. Someone was telling me earlier about a math trick where you guys like are multiplying by 9. Like if you're multiplying 5 times 9, you like move your 5th finger in, and then you're like, oh, it's 45. It's just a math trick. So if you're multiplying 3 times 9, how does that work? So if you guys are doing like 3 times 9, you move your 3rd finger in, and then it's 27, 1, 2, and then 7. Yeah. 3 times 9 is 27.
I know, but like with you count, that's
I can't separate my fingers like that. Look at it. All right, so anyway, it's just a math trick. The moral of that story is crisscrossing is just going to be a math trick you guys have to find the greatest common factor. Yeah. Okay? Get that? Crisscross the charges to make a neutral atom. Molecule. Okay? All right, next step. This is written in there for you guys. You're going to double check. Make sure there's no charges on a neutral molecule. So all your molecules that you'll see will not have a positive or minus anywhere in them. If they do, they are wrong. Okay, these should all be neutral. Okay, the S route though, so does it have a polyatomic ion in it? Yeah. Okay, so it either ended in ATE, ITE, or in the form or the name somewhere we saw hydroxide, cyanide, or ammonium. Okay, so yes, it does have those. Okay, the first box, this element consists of a polyatomic ion. Where are polyatomic ions at? No, well they are going to be in your head. Yes, you are going to memorize them. But since there's only one thing that you guys have to do with those polyatomic ions that's memorizing, you guys will have that sheet available to you. So you can just look on your cheat sheet, the one that says chemistry stuff you need to know. That is your cheat sheet. The only time you guys have to fly without that cheat sheet is where you guys take the quiz on polyatomic ions. Every other time you guys should have that cheat sheet with you. Tests, other quizzes, stuff like that. The biggest thing is I want you guys to memorize them so you can recognize them when you see the name. It will help you.
So we didn't do anything in class to help memorize?
I get you guys flashcards. That's nice. That was neat of me. Negative, man. I guess.
Oh, yeah, your battery.
Yeah, a little battery.
On my iPad?
Yeah.
You think
I'm
they have like
starting
a
to
built-in
think you'll be
charger?
better off just taking the class at Caitlin's house because, yeah,
It's like in the old days.
Okay, watch this. This is going to be very, very sneaky. You guys are going to be so impressed.
let me tell you to do hold on.
Write the symbol and the charges for the metal in the polyatomic ion or the polyatomic ion in the nonmetal before this dies. Okay.
Extension cord? I like it.
This is not a safety hazard. I repeat. This is not a safety hazard.
Yeah, just watch me trip through on the cord when there's a fire and die. Because I can't
there's
get
not a
in.
fire.
It's all your fault.
Let's hope this doesn't cause a fire.
If it does.
Like in a Christmas story with the
Look,
Christmas
I'm not saying
tree.
CJ sticking
Yes.
paper clips in it.
Or a Christmas vacation.
Yeah, that's it.
It's not working.
Don't tell me what to do.
I really don't know if it's not working.
Hey guys, guess who's going to have to retake chemistry next year? Probably Grace.
Not me.
Oh, look at that. It turns out you actually did fail all your tests. My bad. You got that?
Almost.
I plugged in 3 extension cords in that time, and you guys still don't have that written down?
Not because you plugged in so many extension cords.
You were worried about safety hazards. That's not awe. That's shock, literally. But it's pun. Fuck, you missed my pun. I said that's not awe, that's shock. But it. Get it? Electricity.
Do you have Kendra in class?
That's a good one.
Yeah.
Does she do puns to you?
No. I think she's scared of me.
Not Buck.
All right, guys. All right, last but not least, if those two do not cancel out, if those don't make a neutral atom, then you guys are going to have to crisscross. Okay? Like Crisscross of Criss and Cross, the band from the 90s. Crisscross and make you want to jump.
Yes! Oh my god.
I was thinking of jump again.
Yeah. Do you know Chris of Criss-Cross died? Ironically, also they were both named Chris. Chris died like 2 years ago. Chris of Criss-Cross. Chris times 2. One of the Chris's died.
How do you die?
I probably drug overdose, but I don't want to speak illy of the dead. Okay.
We're a rock band, Garrett.
They're not?
They were a one-hit wonder.
Yeah.
I would say hip-hop or rap. But they were also like 13, so I don't know if you call it rap.
Oh, it sounds
If it's a 13-year-old.
Yeah.
Do we need the 3 exclamation points?
Yes, because that is very important. I just really want to emphasize my point with not 1, not 2, but 3 exclamation points. Okay? We good? Good, good. You guys got it? Got it? Good? You got it? Good? Good? Anyone not?
I feel like you're about to start like.
You guys set? Shh. Quiet, guys. Hey, guys, quiet. 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 Now we good? Now we good? Okay. All right, very last one. Double check. Make sure you guys got a neutral atom. Okay, so let's do some examples. We're going to do some examples. First thing I want you guys to write is somewhere on there I want you guys to write these 3 little stars. Okay? Only ionic compounds and an ATE or ITE, that usually signifies that we have a polyatomic ion. Okay? Ionic compounds with only 2 elements and an IDE. Okay, so we might see some in an IDE as well. What that tells us is there's only 2 elements that go into it, so a metal and a nonmetal, not a polyatomic ion and something else. Last but not least, there in your guys' name or your anything that you will not ever find a prefix. There will be no di, tri, mono, tetra, penta, all those. Okay, 0 prefixes will go into naming these things. No prefixes. Don't even think about it.
Ever?
Not ever. Not in ionic, at least. Not today, not now, not ever.
Scientists discovered
No.
Well, taking the Atlantic Ocean.
Near the Bermuda Triangle.
Why are you talking about it? It's like a giant.
So many planes keep disappearing from there.
I don't understand.
It's an electromagnetic.
It's aliens.
That's who built the pyramids, dude. There's no way that a whole bunch of fancy people could just go rock things.
Dude, what if it really was aliens?
I don't want to think about it.
Like, hey, they did some good work, but how are they more capable than we are?
Well,
Like, does that, if there are aliens, and aliens, like, use, like, a laser beam to put these giant rocks and stack them on top of each other, doesn't that make you feel like a stupidly inferior human race? Like, why don't we have laser beams that can build pyramids? But a boy. Alright, guys, quiet, please. Shh. Alright, let's take a look through. We have 5 examples for you guys. Okay, the first one, if I give you guys the name sodium chloride. Okay? Very first thing you guys always check, now that we've talked about covalent and ionic, you guys need to check and say, alright, are we dealing with ionic in this case? So what's the first thing we look at, Tristan?
If it's compound, if it's a metal or non-metal.
Is this a metal or non-metal? Metal or a non-metal?
A non-metal and a non-metal. A metal and a non-metal.
Sodium's a metal. It's on the left-hand side with all those other metals. Okay? So we know it's ionic. What's the next thing we're going to look for then, Ivan? What's the next question we asked ourselves?
Does it have a polyatomic
Ion. Does it have one of those polyatomics? So what we look for is, does it end in AT or ITE? Or hydroxide, cyanide, or ammonium? Does it have any of those in it? No, it does not. Okay? So we look at this. All right, that means it's just 2 metals, so we go the no route. It says write the name of the metal, or excuse me, write the symbol for the metal, and the charge. What charge does sodium form, Destiny? A positive. Then we write the symbol and the charge for the nonmetal. Devaney, what charge does chlorine form? 1 minus. Okay, guys, quiet, please. Stop talking when I am. If you put a positive and a minus together, do they cancel each other out?
Yeah.
Yes, you are done. All you have to do is rewrite the thing. So it should say NaCl. Okay? At the end of this, there are no positives, no negatives, nothing in it. Okay? NaCl is your formula.
Why does NaCl?
Salt.
Oh, it's salt. Okay.
That's a salt. You just assaulted me.
This cover that took us out of season. Are you kidding me?
Yeah.
Gosh dang it.
What did you say?
I'll have to spice up my repertoire a little bit more for you. All right, number 2. Guys, quiet. Huh? Good. It was good. It was a good dance. It was a good victory dance. Magnesium phosphide. Is magnesium a metal?
Yes.
Yes, it is on the left-hand side with every other metal like iron. Okay. What does it end in? IDE. So it is not 8. It is not I. Do we have hydroxide, cyanide, or ammonium anywhere in that? No. So that means it's only 2 elements. We write the symbol for the first and write the charge. What charge does this form, Rachel? 2 plus. Phosphorus is P. Make sure you guys are using the correct symbols. What charge does it form, Merritt? 3 minus. So we've got a positive 2, a negative 3. If we put those together, would they cancel out, Katie? No, right? If you guys add 2 or take a positive 2 and subtract 3 from it, you get a negative 1. That is not a neutral molecule. So if that is the case, we need to crisscross applesauce. According to those two yahoos. So what crisscrossing looks like, guys, is you take the 2, okay? You don't have to worry about the plus and minus. This is just a math trick. You guys take the 2. You're going to move the 2 down here. We're going to take the 3. We're going to move the 3 down here. Okay, so your guys' final formula will be Mg3P2. Okay, tomorrow we're going to look at why this is. Why does this math trick work? But let's talk about it right now for a second. Okay, we have 1 magnesium with a 2 plus charge. Okay, but now we have 3. So how many total positive charges do we have? 6, right? 3 times 2 is 6. Okay, then we move the 2 down here. We have 2 phosphoruses, each with a negative 3 charge. How many negative charges do we have? 6. Now we have a positive 6, a negative 6. Now those cancel out. So that's why that math trick works. What we're going to do tomorrow, tomorrow, we have this little puzzle where we have like 3 prongs on the phosphorus. How many of those do you have to put together till they're level? Okay, it'll make more sense when you guys see the little puzzle pieces. Okay? Example number 3, calcium carbonate. Mick, is calcium a metal or a nonmetal? It is a metal. It is on the left-hand side with everyone else. What do we notice about this other part? Let's see here, Devaney's got this. If it has an ATE, what does that mean, Jocelyn?
It means you go down the yes one.
We go down the yes side. So yes, it does have a polyatomic ion. So we can go ahead. We write the name for calcium. What charge? Anyone? 2+. Okay. Carbonate's a polyatomic ion. We know this already. Where do we find our list of polyatomic ions? On our cheat sheet, our chemistry stuff we need to know. Okay. So find CO or carbonate on there. What is it, Tyler? You guys, can you bring my feather? I'm filming this. Do something. Set it over to the side right now, but don't interrupt class, please. Okay, what is it? So CO3, 2 minus. When you guys are dealing with these polyatomic ions, treat them as 1 unit. Okay? So that CO3, that whole thing has a negative 2 charge. We do not want to change anything about that C, that O, and that 3. Okay? Carbonate needs to stay the same. Okay? That whole thing has a negative 2 charge. So think of these polyatomic ions as 1 unit, like a new element that you just learned. Okay? Except it's capital C, capital O, and then a 3 O's. So 3 oxygens. 1 unit. Okay? Carbonate's 1 new thing that we learned about. Okay? If we put those 2 together, are they going to cancel out? Yep, we got a positive 2, negative 2. That would equal 0. So your formula is CaCO3. Make sure you guys are writing the proper capital letters and lowercase letters. Okay, I'll see kids that'll write like a little o. Big C, little o. Well, that's no longer carbonate, CO3. That's cobalt. Okay? So make sure you guys are capitalizing properly. Okay? Let's take a look at beryllium phosphate. Beryllium phosphate. Vicente, is beryllium a metal? Yes. Okay. What else do we notice about this, Ivan? It ends in ATE. So what does that mean, Grace, if it ends in ATE? It's a polyatomic ion. So we write beryllium forms a 2 plus charge. Phosphate is what, Libby? So PO4, this whole thing has a negative 3 charge. If we put these 2 together, do they cancel out? They're afraid not. Then what do we got to do, Buck? We got to crisscross. With this, though, when we are dealing with a polyatomic ion, we want to make sure that we don't mess up the integrity of that polyatomic ion. It needs to stay as PO4. Okay? So when we do this, if we are pulling a number down after our polyatomic ion, we need to put parentheses, and I'll show you why. Okay? So the 2 would go down here, the 3 would go down here, so we would have BE3, parentheses, PO4, parentheses 2. Okay? If we did not use those parentheses, then it would BEB, BE3, PO42. That's significantly different, right? This one says, all right, I've got 2 phosphoruses and 8 oxygens, or 2 phosphates. Okay? This one says, I have 1 phosphorus and 42 oxygens. That's not the right thing, so make sure you guys do those parentheses, okay? We want 2 phosphates to balance that out. Cool? Easy peasy. Last but not least, iron 3 hydroxide. We've added something new to this. What have we added? S3. Yeah, it is a transition. We'll get there. All right, so we know iron's a metal. Okay? Not only that, but iron is a transition metal. What's special about our transition metals?
Check the chart to make sure they're...
Right. You have to check the charge. You got to go check those little numbers over the symbol. So Fe has a little +2 and a +3 over top of it. So that means that in this case, iron can either form a 2 positive or a 3 positive charge. How on earth do we know which one it's going to form? We wrote it in the name. Okay? So it doesn't matter which one's bold anymore. It matters what we've indicated. Yeah, that's right. We also know hydroxide is what? It's polyatomic ion, right? Because A, you've memorized those, and B, you guys recognize that from your flow chart. Okay? So iron has a 3+ charge because we said it had a 3+ charge. Hydroxide, OH, that whole thing has a negative charge. Okay? If we put those two together, are they going to cancel out? No. What do we got to do then, Maddie? Crisscross. So our 3 is going to come down here, and our 1 is going to come down here. Do we have to write the 1? Nope. So we're just going to write FeOH3.
No, you need parentheses.
We need parentheses. Good. I was waiting for someone to pick up on that. We need parentheses around our polyatomic ion. This is correct. Okay? FeOH3 is not correct. We want 3 hydroxides, not 3 hydrogens and 1 oxygen.
But how come you're not multiplying by a negative?
It's just a math check. You don't worry. You just bring the number down. You don't worry about the positives and negatives. Remember, it's just how we cancel out the positives and the negatives. Just a math trick to do that. Again, tomorrow we'll work with a little puzzle where you guys get to see how those work, okay? Cool. All right, let's flip back to our flowcharts. Okay, this one is if given the formula.
So you do want parentheses on them?
Yes. Okay, it's a difference. Yeah, the one with the parentheses is correct because we had 3 hydroxides. Okay, the one without the parentheses only had 1 oxygen and 3 hydrogens, so that's wrong. We want 3 hydroxides.
Is it naming ionic?
So naming ion compounds. So this is if you're given the formula. This is how we go backwards from what we just learned. We're not going to get through this whole thing. Oh, we might actually get pretty far. But at any rate, we're going to try. So if you are given the formula, here's how we write the name. Okay, I realize I actually feel like the more I've worked with ionic compounds, I feel like they're easier to name just because you don't have to mess with all the prefixes and stuff. But at the same time, there are a lot more little rules and stipulations that you guys have to know about. You'll be okay. Okay, first question you always ask yourself is this a metal or a nonmetal or 2 nonmetals? Okay, in this case, what's it going to be? It's going to be a metal first. So it's ionic. Really? Hiccuped a little bit.
The web prices is going to shut up.
Okay? So in this case, obviously metal and nonmetal. All right, your next question you're going to have to ask yourself is your guys' metal, which is your first element, chromium, manganese, iron, cobalt, nickel, copper, tin, gold, mercury, or lead. Back to that lead price being so high back. So is your metal Cr, Mn, you guys listen now, you can write them down as I read them. Cr, Mn, Fe, Co, Ni, Cu, Sn, Hey, you, what you doing over there? HG or PB? Okay, so is it one of those metals? Find those metals on your guys' periodic table. What's so special about them? What do we know about transition metals, though? Because we didn't list every transition metal here.
They don't give a crap about the
Why didn't we list something like zinc? Zinc is a transition metal. Why isn't it up on this list?
Maybe those two have more than two ways they can.
You're on to something, Garrett. Yeah, you're close. These ones that I listed, A, are the most common transition metals you'll see. B, they have more than one charge to them. Versus like zinc, if you guys look above zinc on your periodic table, zinc is only ever a positive 2 charge. So we won't need to specify which charge we're using. Okay? Versus iron, iron can be a +2 or a +3. So we'll have to tell the reader, hey, we're using the +3 or the +2 charge. Okay? Manganese is like 2, 3, 4, 6, and 7. So there's 5 different charges. So yes, you guys need to specify it. But again, something like silver, if you guys look at AG, silver number 47, it only ever is a +1 charge. So you don't have to tell me. Okay? All of our other metals that aren't transition metals, like lithium, beryllium, sodium, magnesium, potassium, calcium, those all follow that rule. There's not multiple charges for them. Potassium will always be a +1 charge. You don't have to specify. Woohoo! All right, so yes, we're going to take the yes route first. Yes, our first metal is one of those metals. So you guys will write the name of the metal followed by the charge of the metal. You guys will use Roman numerals. Oh, I love it when that happens. Roman numerals. Okay, and you guys will write the Roman numerals in parentheses after your metal. So like iron, parentheses, I is 3. Okay, 4 is IV, 5 is V. Do you guys know how Roman numerals work? Like the difference between 4 and 6?
No, I don't.
Okay, 5 is V. Okay, if you guys put a smaller unit in front of the 5, like a 1, so it's IV, then you subtract it and make 4.
Oh.
If you put it after the, so it's VI, then you add it to make 6. So again, 5 is V. If you put it before, it's 4. If you put it after, it's 5.
Okay. I'm just making
So,
sure. Like,
yeah.
To the left of you.
So like 7 would be VII. Okay? If you wanted to do 3 other than just writing III, you would do IIV. And that would tell you before it, I mean, you subtract, listing those I's after you add.
Sorry. It's just 'cause
No, you're fine. I'm glad to explain that because a lot of people don't know. And you guys won't have to use like a whole range. Like I'm not asking you guys to write like 100 on here. You guys will be using like 7 at the most. Okay?
Oh, wait, no, it's
10
10.
is... Oh, is an X. C. C is 100. C is 100. C is a century. Yeah, sorry, I had to think about that one. Yeah, X is 10. So like if I wanted to write 9, I would write IX, and you subtract 1 from the 10 to make 9. I don't think he was listening. Okay, so if I look at this, guys, what you're basically going to do is you're going to uncriss-cross it, okay, to figure out what your charge is. Okay, so if we were looking at like FeCl3 versus FeCl2, if we were to uncriss-cross it, FeCl3, what charge does the iron have? If we were to uncriss-cross that, FeCl3, uncriss-cross it, it would be iron 3. Okay, FeCl2, we were to uncriss-cross that, what's the iron going to be in that one? Iron dose, iron 2. Okay? God, this is a punny class. You guys hands down win the punniest class.
Yes. Well, it means if I get an award at the end of the year.
Okay. All right, ready? All right, no side. If we do not start out with one of these metals, this is a no side. You guys are just going to write the name of the metal. Nothing needed to be included after it. No Roman numerals. Like I said, if it's potassium, you guys just have to write potassium. It's always going to be a +1 charge. You don't have to specify. This is the no. This is now the no route. Okay? We're going to come on what they merge upon on this next slide. Cramping up? Getting carpal tunnel? You'll be okay.
Say what?
It's attractive when your hand looks like this. Grab onto my strong hand. Okay, Next question you guys are going to ask yourself. So this is where the two pathways are going to merge again. Does it have more than two elements? Okay. So no would be, does it have two? Yes would mean it has more than two. So write that next to it. No, you guys would put only two elements. Right by the yes, you guys would put more than two elements. No is only two. Okay. Shh. Yes is going to be more than two. Okay. Let's talk about our next pathway then. It's going to be our no pathway. Okay. So no pathway is only two elements. Does it have more than two elements? Yes or no? Do you have that written down?
Wait, so is no less than 2 or true?
Yeah, so if it doesn't have 2 or
So right next to the no, write only two elements. Just right next to that little box that says no, write only two elements. Okay? So what we're going to do is we're going to name the non-metal anion using the suffix IDE. It will end in IDE if it only has two. Okay? Example, sodium chloride, we just have sodium and chlorine. That's two elements. So it's going to be sodium chloride, IDE. What do we use for polyatomic ions?
Your cheat sheet.
And ATE and ITE. Okay, with the exceptions of those exceptions. Okay, so again, two elements, it's always going to end in IDE. There's no exceptions to that one, so that one's nice. There's exceptions to the next one, but nothing you guys haven't seen already.
This is our first trip to that block.
True story. Okay, you guys got it? All right. Then you guys are going to double check your formula. Remember, no charges on a neutral molecule. That should be in there for you guys. That was your final step. Okay. Let's go with the yes. Does it have more than two? Yes, it has more than two. So it has more than two. We can count it and say, all right, that has at least 3 or 4. Yes, route? Whoa! Goo! You guys are going to find the anion on the polyatomic ion list. Okay? Find the formula in your handout and use that name. So if it's NO3, you guys would find NO3 and say, oh, that's nitrate. Okay? Make sure you guys are matching the formula and the name up properly. You guys don't have to write that if you don't feel that's going to be an issue for you guys. But it's the same thing like kids, I'll ask them to write calcium and they'll write C for carbon. Okay? Make sure you guys are writing the correct thing. Same with your polyatomic ion sheet. Okay? The polyatomic ion will end in ATE or ITE with the exception of hydroxide. What's our other one?
Cyanide.
Or cyanide. Okay? We'll talk about ammonium here in a second. Ammonium would actually, it's a positive. It's our only positive polyatomic ion. Where do we put the positive at? The beginning. So it's the one that comes first. That's why our metals are always first, because they're positive. Okay, we want to lead with something positive. Okay, here's the thing about these guys is it's like using training wheels on a bike. Okay? I encourage you guys to actually use them. Use your guys' flowcharts because if you guys don't, you're going to start out with bad habits and you're going to start out doing things wrong. Okay? You're not going to get a pair of training wheels on your bike and ride them around the block once to try it out when we talk about it in class and on our examples, and then never use them again and expect to take them off and ride the bike well. Okay, so use these until you guys get used to them. The more you use them, the quicker you guys are going to get used to them and not have to use them anymore. Okay, practice is key. Use these. It's just kind of like your guys' 5 steps for your Lewis dot structures. Okay, if you guys don't use them, you're probably not going to be doing them right. And I'm probably not going to want to help you if you guys don't even have those in front of you.
Why is cyanide then?
Cyanide's the same. It ends in IDE, but it's a polyatomic ion. So every other polyatomic ion ends in ATE or ITE. Did everyone get this? Almost. Cyanide. You guys know how much my smartboard loves me. Just like this little crazy guy follows me everywhere. Cyanide?
Yeah, I guess
Cyanide, it's one of our polyatomic ions. Okay? Last but not least, here's another exception for you guys. Ammonium is your other exception, but ammonium will come first. Okay? Ammonium's your only positive polyatomic ion, so if you guys do have it in your formula, you guys will have to write the name first. So ammonium is an exception because it is a polyatomic cation. It goes first in the equation, followed by a single anion ending in IDE. So your guys' thing will still end in IDE even though there's a polyatomic ion ammonium in it. Okay? Again, this is one of the reasons you guys need to recognize that. So if you see NH4Cl, you guys don't panic and try to name that like a covalent compound. You immediately see NH4 and go, hey, that's a polyatomic ion. An ion has a charge. We're dealing with ionic compounds here. Okay, this is a polyatomic ion. Learning those will help you guys memorize that. Okay, so you guys' example would be ammonium chloride. And again, ammonium's listed first. Because, I mean, you guys look at that. Do you see one metal in that whole thing? No, but you guys would memorize ammonium chloride or memorize ammonium and know that's an ion and know it's ionic. Okay? So, again, that's one of the reasons we memorize these, so you guys can recognize that. And you're not like, mononitrogen, tetrahydrogen, monochloride. What? No, it's ammonium chloride, weirdos. Oh, we might get some examples in.
No, wait.
Don't.
Don't
Yeah,
do
don't
it.
scare.
Don't do it. Don't do it.
She's up works.
How about now?
No.
How about now?
7, 6,
12,
Are we there yet?
4,
6,
3,
12, 13.
We'll do the examples tomorrow.